are you?
I'm good. How are you?
Good. So are you taking those tests this week? The things that used to be called
Yeah.
PCAP tests?
Yeah.
Only now they're different, right? This year?
It's Park, I think.
But they go on your record this year, don't they? Whereas in the past, I don't think they've ever gone on your record. At least
I'm not sure. Now we do have a computer now, though.
okay.
So.
Well, maybe I'm wrong. I think this is just what some other student told me. But anyway, back to geometry. I got a few geometry questions, and then I got a logic question for you. We'll save the logic question until the end. All right, so can you see number 13? Okay.
Yeah. I can see it good.
Okay. Which of those three statements must be true?
Are we assuming that P plus X equals 90?
Yes, which is a valid assumption because we can see this right angle right there, which makes that a right angle also. And this a right angle, and that a right angle. So we know that we have 4 right angles to start with.
So 1, 2, and 3 are all correct.
Well, let me draw a line representing their line there. Okay, so there's my right angles. But is this angle equal to that angle? It only is if this line bisects the right angle. What if I had drawn my line like this? Now is x equal to p?
No.
Okay. They don't tell us anywhere that we're looking at 45-degree angles here. They just have a diagram with a line. Okay. So, number 1 is false. P does not have to be equal to x, as I can demonstrate by drawing the line at a different angle. How about number 2? Is x plus y equal to 90 degrees?
Yes.
Yeah, because we know that angle has to be 90. And these 3 angles have to total 180. So x plus y does have to be equal to 90. And once again, does 3 have to be correct?
No.
No, and I can show that real easily. In other words, a lot of these problems, it's good to graphically be able to picture it. In other words, I know x doesn't have to be equal to y because I can draw that line like that, where y is now much bigger than x. Or I could draw it like that, where x is much bigger than y. So being able to draw these alternatives in your head or on a piece of paper are helpful. All right, this is a fairly straightforward one. How do I solve this?
Well, x plus 2x minus 20 has to equal 180. So you would solve for that.
Okay, give me the equation I want to write.
3x plus the quantity 2x minus 20 equals 180.
Okay, now solve that. First step for solving it?
Distribute, but you're really just distributing one.
Remove the parentheses, basically, right?
Yeah.
Okay, well, turns out I can remove the parentheses. I don't have to change anything. Now what?
And you 6x equals 160.
You can only add.
Oh, right.
Okay, so what do we have? So first of all, we have 5x minus 20 equals 180.
I was thinking of, please, that was
That's it.
not a good assumption on my part, sorry.
Now what's the next step?
Then you would add 20 and get 200.
All right, and then finally,
X equals 40.
all right. Let's see, what page is this? 139. Okay, so that was lines and angles. Now we're going to talk about triangles.
Right.
Actually is a really excellent geometry primer, these pages I have here. So much better than your textbook's going to do next year. But, and I only say that because of the fact that they start out with proofs. You and I will talk a little bit about proofs before you get into geometry next year, just so we'll give you a little bit of a head start. But this is the kind of geometry you need to know for all your tests, your ACT, your SAT, maybe even some of these tests you're taking now, but probably not, except some of the basic stuff maybe. Okay, so in the figure that they've drawn there, can you figure out the value of x?
Yeah, because all the sides of a triangle have to equal 180, so x would have to equal 80.
Good. That was pretty quick. Yeah. In other words, the way you did it, just to revise, is because that one is 60, this one is also 60. And because that one's 40, this one is 40. So it's all of the interior angles that need to add to 180. But it turns out that that's the same thing as all the exterior angles here. But that's a bit unusual that you get this kind of a problem. In fact, I would say that's the first time I've seen something quite like that. Okay, how about this case here? What's the value of x?
20 plus 40 is 60, so 120, and then 120. Would that equal 60?
Yes. Now, I like the way you did it. You did it the very normal way. But there happens to be a theorem in geometry that says the measurement of that angle right there is always going to be the sum of the two angles in the triangle that it's not vertical with.
All right.
Okay, so as soon as we know this is 20 and that's 40, we know that's 60. Without figuring out that that's 120 and then that's 60. And you can kind of see why that has to be. In other words, if I label all these angles here, we know that 4 is supplementary with 3, right?
Yeah.
4 is supplementary, meaning it adds to 180 with 3. But we also know that 1 and 2, 1 plus 2 are supplementary with 3.
Oh.
So since they're both supplementary with 3, they are equal to one another. So 4 would equal 1 plus 2. So that's where that theorem comes from. And to be honest, there's not a lot of people that remember this one. It's not real common, I suppose, because it's easy enough to work out without memorizing the theorem. In other words, the way you worked it out is good enough. Knowing that theorem only saves you a couple of seconds, but even still, I thought I would mention it.
All right.
Okay, most of these hinge on the same principle. Remember, the section is triangles. And when you're talking triangles, you're generally talking the principle that says the sum of the angles add to 180.
All right.
Okay. So what's x? In as few steps as possible.
For number 3, so x would have to equal 140. Right?
130.
Oh.
In other words,
yeah.
the first thing we have to know is this angle here. That angle is 70, right?
Yeah.
Okay, well, once we know that's 70, x is that exterior angle, and we know that it's equal to the sum of b plus c. So as soon as I get 70 here, I know x is 130. But I can also say, okay, so it's 70 there, that's 60, this has to be 50, this has to be 130.
All right.
Slightly more complicated.
Okay. So, and triangle ABC. All right.
Well, they're
So,
still asking about x in triangle ABD,
yeah.
but you can use all of the information. Remember, when you see a setup like this, you're looking at how many triangles?
Okay.
How many triangles are you looking at?
3, technically.
Absolutely 3. You got ABD, you got BCD, and you got ABC. So
that would equal 25, right? Oh, no.
okay. There's one skill that's going to be extremely valuable to you in geometry, and that is subtracting a number from 180.
Yeah, I realized what I did wrong.
Okay, so what's x?
45.
Okay. Subtract these numbers from 180.
That equals 110.
Okay. I'd like you to do these without a calculator.
Right. That equals 95. That equals 115.
Okay. The harder ones are the ones like this. Sorry.
68?
That's the mistake most people make. Because they do their subtraction from left to right, and they get a 6. But remember that it's always going to be 1 less than that. In other words, the answer is going to be, these numbers are almost always going to add to 7. You see why?
Yeah.
Because if there's a digit here other than 0, then we're going to need some number here, and we got to borrow one from that 8. So whenever you're subtracting a number from 180, don't start with the middle column. Or you can start with the middle column, but know that these two have to add to 7. Okay, another example. The answer?
That would equal...
The first digit I'm going to write is that one right there.
Yeah, 41.
Because I know that these two numbers have to add to 7.
Alright.
Okay? Alright. Okay, you know what bisects means?
No, not really.
It splits the angle. In other words, whatever this angle here is, BD bisects angle ABC. So if angle ABC was 100 degrees, this would be 50, that would be 50.
Alright.
Okay, so that's what bisects mean. Okay, and they want to know the measurement of angle BDC. It looks like a right angle, but we don't know that. Let's see if it is or not. So how are we going to do this? Again, this is a problem where you're looking at 3 triangles. And it frequently is the case that you start your analysis looking at the biggest one.
Alright, so you would have to find out what angle B equals, wouldn't we?
Yep. What is that going to be?
That's going to be 100.
Okay.
No.
That's correct.
Yeah, 100.
Now, just back to what I said earlier, when you're subtracting a number that has a 0 right there, then clearly the answer and this number don't add to 7. Okay? They're going to add to 8 because obviously that's 100 and those two numbers add to 8. But they only add to 8 when these are zeros. Okay? And those aren't hard. Those don't mess anybody up. I could give you any number and say, well, what's the difference between those two? And I know you're going to get it right. So these aren't the ones that are hard. What's harder is when you have an angle like that. Most people are inclined to say 63. They're off by 10.
Alright.
Okay, so always reduce it so that those two add to 7 and you'll have the right answer. Okay, so what's angle ABC?
Triangle.
In other words,
AB.
yeah, angle ABC is what you called angle B. The only danger in referring to that as angle B is there's actually 2 angles in there. In other words, is angle B ABC, or is it ABD, or is it DBC? You see the problem? We can refer to this angle as C, because there's no possible way to misconstrue that. And I can refer to this angle as A. But it's a little dangerous referring to that big angle as B. But what is angle ABC?
100.
Okay, and if BD bisects that angle, what is this angle right here?
Would it be 60?
50. If you bisect something, you cut it in half. So if the whole angle is 100, half of it is 50. So now, this one's 50, this one's 30, this one has to be what?
90.
No? 50
Wait,
50 and 30 is 80,
yeah.
so it's 100.
And then 100.
Yeah, it looks 90, but it's not, it's 100.
So that triangle is not really drawn to scale.
No, it isn't. And you run into that a lot, and that's because they don't want you to be able to answer this by examining the angle or using a protractor or anything like that. They want you to be able to figure it out algebraically. All right. We got 7 minutes. Let me give you my logic problem. You're going to have some fun with this. You might know this one already. You have a farmer. He comes to a river. He's got a boat. He's got a fox. He's got a chicken. And he's got grain. He's got to get all three to the other side. He can only be in the boat with one other thing at a time.
Oh, okay.
Can't leave the fox and the chicken alone. The fox will eat the chicken. Can't leave the chicken and the grain alone. The chicken will eat the grain. Fox won't eat the grain, so you could leave the fox and the grain alone. So the question is, first of all, how does the farmer get everything to the other side and have everything survive? And what's the fewest number of trips he can make to do it? Now, he can go back and forth as many times as he wants.
All right, so first you would have to bring the grain, because that's the only thing.
Good thing.
Wait, no, not the grain.
Good thing. Okay, so he took the grain over, and now the farmer is on this side.
But now the chicken's dead. So first
Yes. Excuse me. You're absolutely right. I didn't even remember my own problem. Okay, so we're going to leave the fox and the grain. We're going to take the chicken. Okay. Now what?
All right.
Now the boat's over
and
here.
then he would go back.
Okay, by himself?
Yeah.
Okay, so now the farmer's back over here.
And then he would bring the grain.
Okay.
Over to the other side.
Okay. So we got the grain over here.
Wait, actually.
And the farmer is still on this. Now everything's over here. The boat's over here. And the grain's not there. Okay. Now what?
And then he would bring the chicken back with him over to the other side.
Very good. David. I just watched a show called Brain Games, and they asked 5 adults to solve this, and none of them could even come close.
Huh. I've seen that show. I like it.
Okay. Now what?
So, and then he would bring the fox with him on the other trip.
Okay. And the fox and the grain are okay together. So now he can come back, get the chicken, take it over. He's got all 3 of them over. Takes a total of 7 trips. And that's the shortest possible amount of time it can be done. That's pretty good. That shows a good ability to think outside the box. All right. Well, you did that so fast. Let's go back and do a few more geometry problems, since we got just a minute or 2 left here. The show called Brain Games, I don't know if you get it or not. It's on Comcast. It's probably also on DirecTV. I don't even know what channel it's on. But it is really good. It is all about magic tricks, the art of illusion, the art of how your brain perceives things when they're presented in a certain way. It is cool. I've learned some magic tricks that I guarantee I could blow your socks off with.
Huh.
But
I think I've seen it before. We have a Netflix account.
oh, you might have. Yeah, it's available on Netflix. In fact, my son saw it on Netflix, and he was the one that told me about it. And it's available on my TV also. So I've been watching it, but it is pretty cool. All right, let's see. They want the measurement of this big angle up here, PTR.
All right.
So let's label everything. The secret of geometry and triangle problems, as you can figure out by now, is to just start labeling everything you know. Ooh, actually, there's a real quick step. Wow, I just realized it. What is that angle?
That's 20.
Remember this exterior angle theorem that I told you about?
Oh yeah.
40 has to be equal to that plus that in the big triangle.
Alright, so it would be 90.
Yeah, and we don't even need this 110.
Huh.
And in fact, yeah, I don't think they intended for us to be able to answer it that quickly. Let's see, this angle here is 40, and if this is 40, this is 30.
So
They ask about PTR. Yeah, that'd be 90. So that would be 30, and we would know that since that's 40, and this would have to be 90 and some, so we'd get there. But we don't need that one right there. Notice that I can change the direction of this line anywhere I want. I can change the angle of it. I could draw it like this, or I could draw it like this, making this angle not 110. And it doesn't change the outside triangle at all. So this angle right here cannot be relevant to what this angle is up here.
alright. Cool.
All right. Well, we can stop there and pick up from here next time.
Alright.
All right, David. I will talk to you next week.
Thank you.
Bye-bye.